So let's rewrite it again. So sine of A over 54 is equal to sine of B over 62. 40 over 54 is equal to the sine of B over 62. That's the way it should have been written. We're going to cross multiply. We're just going to go sine of B is equal to 64, 62 sine of 40 over 54. Okay? I'm going to get a little bit different number. 62 times sine of 40 and parentheses divided by 54. It's going to be 0.73. Take the inverse sine of the answer. Approximately 48 degrees. Okay, that's a little better. That's the answer that they have in the book. Now what happens is, since A, excuse me, if A is less than B, which is the case, this is going to be less than 62, then we're going to have two triangles. Okay, here's the first one, and we talked about it earlier. The second one is going to come out right here like this. That's going to be 54 as well. So we have to cover for the green triangle right over here too as well. We know one thing. I'll give you a little bit of a hint to find the little triangle. Since this is 48 degrees, we know these are equal. This is going to be also 48 because it's a not right triangle, excuse me, an isosceles triangle. So this is going to be 48. What's the measure of this angle right over here? Well, it's going to be 100, supplementary to that, it's going to be 180 minus 48 degrees. So looking at this triangle, and I'll let you figure that part out. It should be 40 and then 132, and you can figure out the third angle right over here for the second triangle. Okay, sometimes it's easier to redraw it. That's going to be 40. That's going to be 132. That's going to be 8 degrees then. And then this is going to be 54. It's going to be 62. And then you can find out the third side using the law of sines. Okay? So let's actually do some problems here. Page 3. We'll do problem number 1 and see what happens. It says for each triangle below, this is on page 344. Most books will give you problems that are similar to this. They actually give you angle A is equal to 30 degrees, B is equal to 40, and little a, which is opposite this side, is going to be 10 feet. Solve for B, angle B, that's what we're looking for, and use the results to explain why the triangle has the given number of solutions. And they all already tell you that there's going to be no solutions for this. Let's try to figure it out. Okay? First, we're going to try to draw a triangle, if it actually works or not. Angle A, that's 30 degrees. That's 40. Always the side to the left. And that's big B, little b, and little a is going to be 10 feet. And so you're going to use the law of sines. Sine of 30 degrees over 10 is equal to the sine of the angle B over 40. We know that the sine of 30 is 1/2. And then cross multiply, half of 40 is going to be 20. It's equal to 10 sine of B divided by 10. Getting rid of the zeros. The sine of B is equal to 2. We know that the sine of any angle greater than 1 does not exist, so therefore no solution. And Professor McKee wants you to try to figure out why that happens. the way it happens. If you draw this to scale, it's going to look something like this. That's going to be about the 30-degree mark. Let's suppose that's 40 right here, and then this is going to be about 10, 20, 30. It's a little bit bigger, but the hinge effect goes into effect. This one's fixed, 30 degrees. Then use my green for this. This is, every time I use green on this one, it's going to be fixed. This one's going to be fixed. This length is going to be fixed. This angle is not fixed, so we can move it back and forth, and you notice it'll never touch it. In fact, this is the height h. You have to have that minimum height. Well, let's try to figure out what that minimum height is, okay? We're going to use SOHCAHTOA now. The sine of 30 degrees is equal to h over 40. If you solve for h, it's equal to 40 times the sine of the angle 30 degrees. The h is equal to sine 30 is 1/2, 40 times 1/2 is 20. The minimum height you have to have is going to be 20, and since this is 10, it's not going to hit this side, side C, that is. And so that gives you the reason why it will make zero triangle, therefore no solution. It becomes apparent a little bit that you have to have a minimum height of h. So we're going to use this to create another rule. If b, that's our b, times the sine of a, that angle, is greater than little a right there, then there are no triangles. If b times the sine of that angle is greater than a, less than a, but a is less than b, this side right there, there's going to be two triangles. But a is greater than b, then there's going to be one triangle. So you have a lot of rules of the ambiguous case, the unclear cases. So you got to make sure you got to know some of this. It's in the book. It's sometimes a little bit bad. You're going to have to muddle through some of the reasons why that happens. Okay, and of course, if a is greater than 90 degrees, then either 0 triangles or 1 triangle. Okay, so that's the information set. So let's try another problem, number 6. Number 6 says that a is 20 degrees, b is equal to 40 centimeters, and little a is equal to 30 centimeters. Oh, they use meters, centimeters, doesn't really matter. Show that there's two triangles. You noticed earlier that a is greater than 90, there's going to be 0, 1. And of course, in this situation right here, a has to be less than 90 degrees. That's the case right over here. A is less than 90, which is equal to 20. And definitely a is smaller than b, so therefore we're going to have maybe 2 triangles or 1 triangle or no triangle. But let's see what happens. So let's use this rule right over here. This one located, where is it? Oh, here it is right here. B times the sine of A, angle A, and then we're going to put a little question mark right there. It's going to be, and then little a is right over here. So B is 40 times the sine of 20 degrees. I'm going to put a circle right there, and that's going to be 30. Sine of 40 times the sine of 20. I use the calculator for that. It comes out to be approximately 13.7. And then 30. This is much bigger. A has to be bigger. This A has to be bigger. You're going to have at least one triangle now. We know that B is going to be bigger than A. Locate it right here. B is going to be bigger than A. We're going to have two triangles. So at least one triangle. We're going to have, therefore, two triangles. Let's actually solve this out now for the triangles, and they even tell you that it's going to have two triangles. So we're going to draw it out. That's about a 20-degree angle. We're going to try drawing out the outer triangle first, and then we can figure out this inner triangle. A is, let's label it 20 degrees. B is going to be 40 right here, and little a is going to be 30. Using the law of sines, let's call this big B, little a, big C, little c, and then that's equal to little b. Sine of 20 over 30 is equal to sine of b over 40. We're going to cross multiply. 40 times the sine of 20 is equal to 30 times the sine of the angle b. To get rid of that 30, we're going to divide by 30. To get rid of that sine, we're going to take the sine inverse. And I'm going to use my calculator for that. Sine inverse of, I can get rid of the zeros in the front right here because they're being multiplied. Get rid of your zeros. 4 times the sine of 20 divided by 3. Approximately 27 degrees. And so that's 27 degrees. And then we can figure out what little c, big C is. We can go 180 minus 30, excuse me, minus 20 minus 27. That's going to be 133 degrees. So big C is equal to 133 degrees. And we're going to have to figure out what little c is. So we use the law of sines again. Sine of 133 over little c is equal to. I would use this one instead of this one because we actually figured out this one. It could have been wrong, but this one's given. So we're going to use sine of a over 30. Sine of 20 over 30. Cross multiply. 30 times the sine of 133 is equal to c times the sine of 20. To solve for c, we're going to divide by the sine of 120. I'm sorry, sine of 20 degrees. Using my calculator, 30 times the sine of 133 and parentheses divided by the sine of 20. And this is going to come out approximately 64. Little c is approximately 64. I didn't look in the back of the book